and he'll be doing the bulk of the presentation this morning. And my name is Neill Hart. I work in the planning strategy function at CSI, and I'm just going to start with a couple of words of introduction before I hand over to Paul. So with no more ado, let's get kicking off. At CSI, we're looking at technology, but not technology for its own sake. We're very much focused on outcomes, and I think this is nothing more appropriate than in the area of cyber threat and cyber protection. We look at optimizing our performance, providing applications on demand, certainly a huge focus on cloud computing. We're doing this to give our clients the edge they need to compete in a vastly changing world. We see three main forces around digital transformation: acceleration, disruption, and threat. With digital acceleration, there's nobody has any time to wait around anymore. People will just abandon a shopping cart if a website doesn't respond fast enough. And that acceleration is helping disrupt the market. There's almost no market that hasn't been seeing competition from non-traditional competitors. If we look at something like Uber, it's a huge force in transport, but it actually owns no vehicles. You look at something like Airbnb, changing the world of accommodation, but they don't own any property. So, together, we're looking at that disruption of the market with the acceleration that digital transformation gives us. And of course, on the back of that, a huge amount of new threats from the digital world that we're living in today. At CSI, we attack these problems through a range of different capabilities. And today, of course, cyber is the main one that we're going to be looking at with Paul in a second. As I mentioned, it's not technology for its own sake, the outcomes are at the end. If we look at that spaceman, the amount of technology built into that spacesuit is immense, but it wasn't the point. The point was to keep the chap alive in outer space. So we're always going to keep an eye on those outcomes, whether it's growing the business, saving money, innovating, or protecting data and technology. And today we're really looking at that protect, building cyber walls, if you like, around the business so we can operate in this new digital world. The process that we deliver, we call it the 6 I's, from identifying and imagining, setting up a solution, integrating it, improving it, but all the time immunizing, putting those predictive and perpetual monitoring around the whole solution that we want to do. And the reason I've put this slide in is because what we would like to do is invite anyone on the call today to take advantage of our Identify and Imagine workshops around AI, which helps us get started, finding out what the solution is, identifying a business challenge and addressing it. What we don't want to do is say there's a whole bunch of data, what can we do with it? We want to start identifying that business problem and then applying artificial intelligence and cognitive solutions to that. So I would invite anybody on the call today to follow up with CSI, and we can, at no cost, have one of these workshops to try and get started. If we look at cognitive specifically, why are we talking about it today? I think the age of implementation is on us, with data and performance coming together in a way that hasn't really been available to us up until very recently. Data means better learning. It's the fuel for AI. The more data we have, the more accurate the model becomes. Of course, that comes along with the need for immense compute power. GPU powers technology until recently has been pretty expensive and out of reach for most businesses. But today, between digital business, social media, Internet of Everything, sensors, and everything from cars to fridges, there's a huge amount of data that we can use to fuel AI, and we now have affordable high-performance compute available as pay-as-you-go. So I think these two things have come together to get AI out of the laboratory and putting it to work. And if we look at the two creative processes, invention is about creating something for the first time. And you could argue that AI has been around since the 1940s, the 1950s, with people like Alan Turing. But the innovation is about putting that to work. And I think that is really where we are at the moment. It's been invented, it's come out of the laboratory, and it's time to start solving some real world problems and innovating fearlessly. With that little introduction, I'd just like to hand over to Paul Risk, who's the CTO of Ignition Technology, and he's going to run us through what AI can do in the world of threat protection. Over to you, Paul.
Lovely. Thank you very much, Neill. So good morning, everyone. Firstly, a big thank you to both Neill and Leela for inviting me to talk to you today. As Neill said, my name is Paul Risk. I'm the CTO, one of the co-founders of Ignition Technology. So not only does that mean I have the best surname for somebody that works in cybersecurity, it also means that my job allows me to both look at, play with, and talk about technology all day. Now, over the last sort of 20 years or so, I've worked for the vendors that have created these technologies. I've worked for the resellers and the MSSPs that have implemented these technologies, and also several distributors whose job it is really to discover and find those next bits of technology. And in almost all of those situations, at some point, I've been the person or part of the team actually defending the corporate castle from all of these attacks as well. So I'm going to try and talk today about what is seen from both the attacker's side and the sort of defending side as well. Now, my topic today is all about the challenge and opportunities of AI-driven threat protection. We're actually going to see all sorts of weird and wonderful things over the next sort of 25 or 30 minutes or so. You're going to see how to teach a computer to play things like Super Mario Brothers, and trust me, there is a relevant link to that as we get into it. You'll also see how to create your own ransomware, and more importantly, how to use AI to help protect your company against all these things that you might see. So before we do all that, though, a very quick tiny bit about Ignition. So we are a distributor, or a distie for short. For most of you that might be on this session today, you probably don't necessarily know what that means. You don't really have any dealings with distributors. Actually, our customers are the likes of people like CSI. But really, we are just a filter for places like Silicon Valley and Tel Aviv in Israel. They're your two typical hotspots for all sorts of exciting and interesting technology. And give you an idea, actually, when we started the business back in 2015, just in 2015 alone, there were over 5,200 startup cybersecurity companies in just Silicon Valley and Tel Aviv. So, you know, it's quite astonishing to see the number of technologies, the amount of tech that is in the market right now. We like to try and keep things quite simple. So really, we divide our portfolio up into typically three pillars: identity-based technologies, endpoint-based technologies, and cloud-based technologies. And we do have a hugely experienced team. For anybody that is on this call today, even if you've never heard of or dealt with Ignition before, you might recognize some of those names towards the bottom. So if you've ever worked with Palo Alto Networks or F5 or FireEye or Fortinet, actually it was the team of people in this business that first brought those technologies to the UK over the last sort of 10, 15, 20 years or so. So it does mean that normally we're pretty good at picking the next big thing in the world of cyber and networking and computing technologies. Doesn't mean you get them all right, but we've got a pretty decent formula in order to pick what we think is going to be the next interesting and exciting technology. And really, this is our why. So every company, in my opinion, should have a why. Why do you exist? Why do you actually do what you do? This is really the best visual that I can give you as to our why. So it's actually not a slide that's put together by us. That graphic in the middle is put together by Momentum Partners every quarter. It's called their Cyberscape. And what it essentially does is it divides technology into different buckets or to different areas. So really, over the next 2 years, the fastest growing areas of cyber are predicted to be in the endpoint security space, which is what we're going to spend quite a bit of time today talking about. So that's up towards the sort of top right. And down in the bottom left as well, you've got identity and access management. That's predicted to be the second fastest growing area of cyber over the next sort of couple of years. And it's interesting that of all these logos that are on this slide, only 50 of these vendors actually have revenues over $100 million. And that's part of, again, our recipe for when we pick something. It's great if you've got a great idea, but we need a great idea that actually, you know, people are consuming and using, and that company is stable and they're going to hang around. One other statistic on this slide before we move on is that there is only one unicorn that is on this slide from back in 2016. And a unicorn is a company valued at over $1 billion. So again, we're going to be talking about that technology as we go through this today as well. Last little slide before we dive into the main meat of today's discussion. Really our goal as a business is about creating value for our partners, again, like CSI. So really the ones just to focus on is probably the sort of first three, in particular the first two. So technology. So the guys at CSI, we've had a wonderful working relationship with them over the last sort of few years. They absolutely embrace some of the technology that we bring over to the UK and EMEA market. And then they take that and wrap their services and solutions and their offerings around those pieces of technology. And the other value that we like to give our partners as well is our people. So much like myself being here today to talk to you all, we've also got a whole pre and post sales team of people and marketing teams to again help our partners take these technologies out to market. But that's enough about us. Let's talk about today's main topic. And I wanted to start with this sort of statement that there is AI and there is AI. And what do I mean about that? Well, to be honest, of all the vendors that I now look at on a weekly basis, pretty much every vendor comes to me and says we've got some sort of AI or machine learning capability in our product. And machine learning is really just a subfield of artificial intelligence. It's really the thing you use to make the machine learn something and actually allow the machine to actually teach it something, whether it's about teaching it what's right from wrong, what is malicious versus good, what is spam versus not spam. It's really ML that is that process of getting the machine to learn. And what I wanted to show you here is that just because a data sheet or just because a vendor says that it has AI within it, I'm just going to show you here how easy it is actually to write your own machine learning program in just 6 lines of code. Now, this is not going to get very technical, so don't worry if you're on this thinking, oh my God, this is going to be straight over my head. We're going to use a very simple framework here called scikit-learn, and the goal was to write a piece of machine learning code to tell the difference between an apple and an orange. So not very difficult, but again, in the world of cyber, this could be telling the difference between a malicious program or a good program, or a piece of spam, or a piece of legitimate email. So I appreciate that on some of the screens this might be a little bit small. All the slides are being shared afterwards. And again, if you've got questions as we go through this, you can put them into the little chat panel as well, and I'll make sure I address those at the end. But those first little 3 lines of code on the left-hand side basically say we're going to use this machine learning framework. It's going to define 4 pieces of fruit. The first one is 140 grams in weight, and it's a smooth texture. The next one is 130 grams in weight, it's a smooth texture. The next is 150 grams, it's bumpy. And the final one is 170 grams, and it's also got a bumpy texture. And we're also telling the machine those first 2 were apples, the second 2 were oranges. There is nothing there that is particularly difficult to understand or complicated. It's hardly rocket science. These final 3 lines is the entirety of the rest of the code. Now, because machines like to work in ones and zeros, we've just removed some of the words like smooth and apple and changed it for ones and zeros. But that entire piece of code there in that second box that's appeared has basically said, use what you've learned above, those things I told you about, to now make a prediction. And that final line in the code, line 6, where it says print, I'm going to tell you, if I have something that weighs 150 grams and it has a bumpy texture, what do you think it is? That is the job of the code. And the final piece, just to show you here, is that we run the piece of software. So we run this Python bit of code, and it has spat out an answer, and it's given us the answer 1. So the program now thinks that that piece of fruit you described is absolutely an orange. Now, again, you might be thinking, where am I going with this? The point is, in 6 lines of code, you have now written an AI or machine learning piece of technology to do something. So again, imagine this in the world of picking malware versus good software. Imagine this about spam versus non-spam. As long as you give it enough samples, that is it. So the point I'm trying to make is that there is AI and there is AI. You will see a lot of vendors that talk about AI and machine learning. We're going to show you today some absolute extremes of this, which is how you really do AI and machine learning nice and properly. Now, another example I wanted to show you, I said we talk about Super Mario Brothers, so here it is. So actually, any of you that have had an old console, you probably recognize this level that you can see right now. It's the first level of Super Mario Brothers. And it just looks like that there's somebody here just playing this particular level. The interesting thing here is this is not a human that is playing this level. So in fact, you can have a look at this on YouTube yourself. If you Google, it's actually called Mar.io, so MAR-IO. And it was a guy that basically was experimenting with machine learning, and he wanted to teach the computer how to complete a level of Super Mario Brothers. And what's interesting when you watch the video, it starts off with the screen on the right-hand side where it just sort of sits there. The machine has no concept of what left or right is, or jumping up and down, or what monsters are and baddies and what coins are, and jumping over holes in the ground. No concept whatsoever. So it actually just stood there for quite a long time before it figured out it could use the right key, and if it used the right key, then the Mario character would move along. And the first thing that happened is it kept pressing right, and then the character fell off the screen down one of those holes, and he died, and he started again. So the machine started to learn, okay, well, that's obviously a problem. What can I do to get over these holes? And eventually it figured out there's a jump button. So now it would press right, and it would then press jump at the appropriate time to actually jump over those particular holes in the ground. But then it was the first time it encountered one of the baddies, and it found out that as soon as it ran into one of the baddies, that was bad, and again it died. But it was fascinating to watch. The machine basically built its own neural network, and in fact, on that picture on the right-hand side, the sort of box that's sort of slightly grey-browny up the top left is actually how the computer sees itself in the game, and that little sort of red dash is itself, and it can see the buttons on the right hand side, and all those logical links of those green and red lines between everything is it building its own neural network and figuring out how to complete the level. If you do watch the final video online, it basically works out that to complete the level, it just jumps constantly. It continues to jump, and it evades most of the baddies. It evades most of the holes in the ground as well. But that is actually a machine teaching itself how to play its own game. So very, very cool. Now, let's get back into the sort of market as a bit more of sort of detail here. So the image on the left-hand side gives you an idea that this is just a snapshot of over 80 different companies that are actually now applying AI and machine learning in a proper way to try and fix cybersecurity issues. So you've got things from anti-fraud and identity management, mobile security. We're going to actually spend a bit of time today talking about predictive intelligence on the left-hand side. In fact, that top vendor on the screen, somebody called Cylance, so C-Y-L-A-N-C-E, Cylance. We're actually going to talk about them. But you've got things like UABA, and I'm going to actually explain some of these terms in just a moment. So you can see there's a lot of different areas, even within AI, cyber, that are using AI and machine learning. And on the right-hand side, I thought that's quite interesting. This is actually 2 years old. I've taken some data from 2017, but it basically shows you the top 20 AI employers in the world based on their average net salary. So if you go back a couple of years ago, Amazon were #1 in that list. There's some big names like Facebook and Intel and Google and Microsoft that you'd expect to see in there. But it's interesting, go back 2 years ago, Cylance were the 9th highest employer of AI and machine learning people in the industry. I think it's 86 different jobs that they had, going back a couple of years ago. So absolutely, we are seeing a flood of very, very clever people come into this space just to see what they can use AI for in order to help in the world of cybersecurity. And what it's eventually created is a number of different technologies. So, how can you use AI now to help with cybersecurity? The first one is things like network traffic analysis. So NTA is the area that Gartner define it as. So this is people like your dark traces or your vector networks or your packet sleds. And the whole idea is they're going to suck in all of the network information of all the packets of data flying around your particular organization. They're going to try and make some sense of it. They're going to do some trending and baselining and then try and look at some anomalies. So if there is some advanced persistent threat that comes into your organization, it will behave a bit differently from the norm across that particular company. You're seeing it in SIEM solutions as well, or SIM-SEM, depending what you want to call it. So essentially you're now applying machine learning to millions of logs that are coming into your SIEM solution. And again, trying to sift through that noise and try and figure out actually what are the things that you need to worry about. There's a whole new area right now called ASOC, Autonomous Security Operations Center. Again, this is another Gartner term, which is really combining those top two together. So there's some interesting technologies in the market right now that take your network traffic analysis and all your raw logs and even talk to other products using their APIs to actually go and figure out what do I need to go and fix in the network right now, and really trying to be a SOC in a box, which is pretty cool. I was introduced the other day to a new technology that does automated penetration testing. So again, not sure how accurate this sort of technology is right now, but actually now you're turning the machine against a company. And you're actually saying to the machine, go and see if you can find a way in. Go and see if you can find a vulnerability, something that isn't patched, an open port, an open service somewhere, and see if you can figure out how to break into this particular company, which is quite an interesting concept. You have UABA, another interesting area, so user and entity behavior analytics. The concept now is that I'm going to go and baseline all of my users and all of the machines. So imagine right now that I had a piece of endpoint software on all of the laptops and desktops across my organization. Imagine it starts to learn what I do as a user. And it says, well, you know what, Paul sends about 200 emails a day. You know, he prints maybe 3 or 4 documents a month. He doesn't really connect any USB drives at all, etc., etc. And if all of a sudden I now start to send a lot of emails to maybe a Gmail account, or my overall responsiveness to email has gone down, maybe I've attached a number of portable drives to my machine, I've started copying a lot of data, and I've started to print a lot of data as well. That is absolutely a change in behavior. And in fact, there are products out there now that are using that to even predict when people might be looking to leave a particular company, or maybe when they might turn rogue inside the company. So you need to worry about those particular individuals. There's even ones you can run what's called a leavers report. It will show you what has Paul done over the last couple of weeks and how has his behavior changed over the last sort of few months. So there's some really interesting technology coming out in that particular space. Identity is also quite interesting. So here's an idea for you. So, you know, we all use a keyboard and a mouse very differently. I type at a different speed and with different gaps between certain characters than somebody else would. In the same way that if I asked all of us on this webinar today to just take your trackpad or your mouse and do a straight line going from left to right with your mouse or your trackpad, we would all do it very differently, even subtly differently, that maybe as a human you can't pick up, but a machine absolutely can. So there's some really interesting technologies now that are even watching how you interact with your laptop. And rather than relying on me putting in my username and password, it can figure out if it's me just by the way I'm touching the keyboard and the mouse. So there's some really interesting identity-based technologies coming out in that space as well, that if it thinks it's no longer you, it could log you out, it could up the level of authentication required as well. So some really good bits of technology coming out in that space. Last couple, so cyber deception. So think of this as almost like honeypots on steroids. So there are technologies out there now that will do a quick snapshot and a view of your existing network, all of your networks, how they connect together, all of your devices, all of your servers and machine names, how are they named, what sort of services do they offer, what's the format of your usernames and passwords, or particularly your usernames across the network. And then actually what it will do is it will go and deploy a bunch of deceptions across the entire network that look like real machines, that look like real users, but in reality they're completely fake assets. So again, using AI and machine learning to copy how your existing infrastructure looks and create fake realities of that as well to catch these intruders, which is very, very cool. And the final one is about endpoint protection. So this is really where we're going to spend the bulk of the next bit of this session talking about. But the point is really, and I think Neill said this just at the start of this, you know, this is not research and development anymore. There are loads of practical applications of AI and machine learning. So it's definitely out of the lab now as well. So let's focus on endpoint security. So again, I'm not going to get everybody to answer this question or come off mute to give me their answers, but just think to yourself for a moment, how often do you think new malware is found in the wild? How many samples on a daily or weekly or monthly basis? So hopefully you've got a rough idea in your head right now. Well, if you go back to 1992, there were about 200 new viruses per month. So, you know, it's actually very easy to write signatures and update a DAT file and update a database and update all of my endpoint agents if there's only going to be about 200 new viruses, as they were called back then, per month. However, if you look at things today, this is a conservative number of 400,000 new samples every 24 hours. Actually, Virus Total talk about 500,000 new samples a day. Symantec did some analysis about a year ago. They actually believe it's well over 1 million new samples every day. So you can see that just the market and the world has changed. You cannot really rely on signature-based technologies any longer to protect you. There is just too much malware out there. And let me explain this with a nice, simple analogy. So this is really the problem with signatures. And again, I try not to get too technical with all of these descriptions. So what we've got here is we've got a sign on a pavement or a sidewalk, if we're being American for a second. And this sign says, right, across this pavement, you're not allowed to ride a bicycle, no rollerblading, no roller skating, no skateboarding, and no scooter riding. However, somebody can come along, some bright spark, and now in this case, they have a unicycle. Now, that is not breaking the rules of what this particular sign says. So what would have to happen tomorrow is the council would have to come and update this sign and add onto the bottom of it, no unicycles. A bit like a piece of anti-malware software on a PC, it doesn't know about the new version of DriedX. So when the new version of DriedX comes out, it adds that to its signature database. But then there's another version of DriedX or a new version of WannaCry or CryptoLocker that comes out. So again, you're constantly in this game of cat and mouse. Somebody is always able to break the rules, break into a system, infect a system before you go and update it. So it's a constant game of cat and mouse. And it's interesting, if you look at the reports from Verizon, they do their data breach investigations report every year. They actually say that 99% of malware hashes are only seen for 58 seconds or less. And in fact, most malware is seen only once. So what does that mean? It means that you could have the largest sign in the world written on this pillar, but you're likely to only see a unicycle maybe once, or maybe a penny farthing, massive old bike, is only going to come down here once. So it's lovely that you've gone and updated the sign and made this sign ridiculously huge and long to read, but actually it's not really that effective. So let's actually see now how the industry has tried to work with this concept of signatures. This diagram, if you start with the black boxes towards the top and it says new attack occurred, and we're going to go around to the right hand side, it starts with when there's a new piece of malware, we have to collect samples of that malware. We have to triage and classify that malware. And we then need human researchers, and maybe we can use some automated techniques to go and again cluster that information together, try and create some sort of signature file that we're then going to give to people to start to push out. Maybe we'll do a test of a deployment, or we'll test that signature against a piece of malware that we've got. And finally, we can deploy that signature update to all of our machines across the company. Now, the point is, if you've got 400 or 500,000 new bits of malware every day, you can see why this just no longer works as a process. It is very time consuming. It is impossible to scale. You can try and use the machines, and in fact there are some vendors out there that are using AI and machine learning to try and write faster signatures, but ultimately the technology and the concept is still flawed, and ultimately you still require a first victim. So I actually wanted to prove this about a year ago. So do we really need AI in order to help this, or is this just a load of noise and a load of FUD, and actually the existing technologies are pretty good? So the challenge I set myself about a year ago was, how easy was it to create a new piece of ransomware? It's very easy to mutate existing malware. So the story goes that one evening, I waited for my wife to go to bed, and then as you do, you get your laptop out and you start doing a bit of searching online. So I did a bit of searching about making sure I can stay anonymous with some Tor capabilities and VPN services. I set up some anonymous email accounts, I set up a Bitcoin wallet, and I found a ransomware as a service site on the dark web. So this is actually what it is. So it was called Satan. I've blocked out the URL deliberately at the top, but it's not that difficult to find these things online. It tells you that Satan is a ransomware. I'm not sure that's the right English, but it's a piece of software that once you open it on a Windows system, it's going to encrypt all the files and demand a ransom of the user. And it even tells you how to make money with Satan as well. And as you go through, I decided, it's free to sign up, so I'll have a little play. I decided to call my ransomware the Rotten Risk ransomware, or Triple R for short. And what I loved as well is that even the baddies, like to use these capture things just to make sure that there's not a load of bots that are signing up to this particular service. And then you go through to this sort of panel, and you go through all your configuration parameters. So I decided that I was going to charge 0.1 Bitcoins, which at the time was about £100, which I thought was pretty reasonable actually, to unencrypt your files and get your data back. I'm a nice guy after all. However, I'm not that nice, because if you don't pay the ransom within 1 day, so 24 hours, then actually I'm going to double it, and it's going to be 0.2 Bitcoins. You go through, and there's even some translation options here. And the thing that was cool about this is the translations are checked manually. So it's not even just using a bit of Google Translate. You write your message in English that says, really sorry, but you need to pay my ransom to get your data back now. They'll go and translate it for you, which is pretty cool. And then this was an exciting moment for me as a technical person, is that you get this little green pop-up that says your malware was created. And sure enough, if I go down to the bottom of the screen, I could see here that I've got a piece of software that I could absolutely download and test. Now, at this point, I've paid no money, and I have no guarantee that this is even going to work. And it gives me a nice little warning here as well to say, do not upload your malware to VirusTotal and or any other online scanner. The reason for that is if I then submitted my piece of malware, my Rotten Risk ransomware, to VirusTotal, they will run it against all the different AV vendors. It will bypass quite a lot of those AV vendors, and then they'll go, okay, this is a problem. They'll start to look at it, and they'll start to roll out signatures. So it means that by the time I actually go to deploy my ransomware to an unsuspecting user, then actually they have a chance to automatically block it already. So that's why you don't do that. So again, download the file, and genuinely the way the story went is that, I then got to this point. I can see on my control panel that actually the cut that I get is 70%. So the people that have set up this Satan site, they actually keep 30% of all of the ransom that gets paid, which again, I thought that was pretty good. If I really wasn't happy, I could just charge more for the ransomware, and they obviously take their cut anyway. And you can see how many infections you've had, etc., etc. So, right now, nothing's happened. Now, at this particular point, and the final bit is you can put in your Bitcoin wallet address to withdraw any funds that you've got. So the whole thing genuinely took less than an hour. Most of that was actually me just doing some research to check how to make sure I was quite anonymous. Actually, it was about 8 minutes, I think, from start to finish, to find the ransomware as a service site, and actually to configure and create that piece of ransomware. But at this point, again, I still didn't know it would work. And in fact, it was so terrifyingly easy, I actually struggled to sleep that night because I didn't have time to test it until the following morning. So this is what I then did. I then went into the office the following morning. I took a machine running in VMware. I just firstly wanted to look up that piece of software. So I called the executable ransomware.exe, so not particularly cryptic. What you can do is you can take what's called the hash of that file, which is like a unique signature of that file. You can paste it into something like VirusTotal, hit the search it button. And again, for me as a technical person, this was quite exciting because VirusTotal came back and said, that file has not been found. We've not seen that piece of malware in our database. So then the final part is to actually run that piece of software. So, we go and run that on the machine. I'll just show you a couple of things here. So there's the executable up the top left-hand side. You can see that I've got a couple of sample documents on this machine that right now are not encrypted. They're plain text and I can view them, and I can see the CPU load on that machine right now. As we go and then run the executable, a few things happen. Firstly, we've got these new processes that are running on this machine right now. So as a user, there's nothing really that's happening on the screen that's any different. It's only because I've got Task Manager open that I can see what's happening. Now what's interesting is you can see that the CPU is now steadily running along. It took about 2 minutes to encrypt all of the files that were on my machine. And if you now look what happened a few moments later, a few things appeared. Firstly, down the bottom right-hand side of my screen, I noticed that all of my file names had pretty much turned to gobbledygook. And I had this window that had come open that's basically just said that, all of your personal files were encrypted. And it gives me, again, my message that I could have written, again, in English that could have been translated to all those different languages. So if we follow this through, just open up one of those files just to prove it didn't just change the file name. It absolutely did convert my file to absolute gobbledygook. I followed the link then on the window behind, and it opens up a little window for me. And on that little window, I can now see that how to get my files back. And I now need to pay 0.1 Bitcoins to this random Bitcoin address. So absolutely, it worked, and it bypassed the anti-malware solution that I was running on this machine at the time. It also says that just check back automatically once you've paid, then you should better get your files back. And the final bit I did is I logged onto my control panel, again back on the dark web, and I could now see that somebody has been infected with my piece of ransomware. Now, I'm not stupid enough to pay my own ransom, but I could have then done and actually hopefully proved that it would have unencrypted all of my data, and I could have got it back. Now, the scary thing about this is that took literally, as I said, 5 or 8 minutes or so to build this. It didn't take long to sort of test it out. I found probably another 34 different ransomware as a service sites on the dark web doing a very, very quick search. And I also checked about 3 weeks later, I checked with another online scanning website, one called nodistribute.com. And actually Trend, McAfee, Norton, F-Secure, Panda, a bunch of these technologies all still did not pick up my piece of ransomware. So the point I'm trying to make here is, what does this all mean? It absolutely does mean that you now need to use a different way. The approach of signatures just doesn't work and it doesn't scale. You need to use AI to help you solve the malware problem. So how do we do this? So there's a new way, feature extraction using machine learning. So again, I'm not going to get everybody to shout out answers or type answers on the screen right now in the chat window. But if I just said to you, what is this image that is on the screen right now? Hopefully, most of you are thinking, probably maybe a giraffe. And I've never actually had anybody else that suggested anything other than a giraffe. They've just had different levels of confidence as to whether they were right or not. Now, if you had thought in your head, that is a giraffe, you are absolutely spot on. But how did you know so confidently that that was going to be a giraffe? And that is because from when you were a young child, or as you've just grown up and you've been lucky enough to go on safaris or gone to see giraffes at the zoo, or you've looked at pictures of them, or you've watched David Attenborough talking about giraffes on the telly, every time you've seen it, your brain has just extracted those features, the colour of the fur or the skin, the length of the legs, the length of the neck, the funny looking ears, the tail, the face. You've extracted all of these features yourself. And another way of thinking of this is actually, if I talk about my kids for a second, so I've got, my youngest is 4, little boy, he was obsessed with animals from a very young age. So when he was probably about 1 year old, we were walking down the street with him in his buggy, and he saw a dog cross the road for the first time. And you could see his little excited face at this little animal that was crossing the road, and he was sort of pointing to it. And he said, "Yes, my boy, well, that's a dog." And you could see him get quite excited and almost try and say dog, but it came out more like duh. But he kind of went, okay, that's a dog, that's a duh. And then a couple of days later, be walking down the street again, and another dog, a different type of dog, would walk across the road. And this time he would point to it and he would go, duh, trying to say dog. And he'd be absolutely right, my boy, that is another dog. And then maybe a week later, we were walking down the road, and this time it was a cat that crossed the road. And he pointed to it and he went, duh, for dog. And you had to go, no, my boy, that is not a dog. That is, in fact, a cat. And you could almost see his little face as he kind of was very confused, because he sort of thought to himself, well, hang on a minute. You know, you told me this small little furry creature with 4 legs and a fluffy tail and fluffy ears, that's a dog. And I've seen a few of those. And every time you've told me it's a dog, now you're telling me that it's a cat. And you can almost see that his little brain was then going, okay, well, what are the differences between a dog and a cat? Is it the size? Is it the way things work between a cat and a dog, or the way they walk that's a little bit different? And I can safely tell you that now that he's 4 years old, he can safely tell the difference between cats and dogs. Even if he doesn't know the individual species of what they are, he can tell the difference. This is essentially what we're getting towards if we use machine learning and AI to tell the difference between between good software and malicious software. So that's exactly what we've done. So getting then a bit more into the technical side of things, this is what people like Cylance have done. They've taken millions and millions of good files, millions and millions of bad files. They basically set up a whopping great big supercomputer running in Amazon Web Services. So it's about 5,000 machines in the early days. They had 15 data scientists originally who had 36 PhDs between them. So a very, very clever bunch of people. And they were actually just telling the machine, look, all you've got to do is figure out what are the features and traits that make good files look good and bad files look bad. And basically what they worked out is there's about 6 million features of a file that can make it look good or bad. And what happens now is once they've built this sort of algorithm, this little mathematical model, it is that gets deployed to all of your machines across your enterprise, your clients and your server machines. And now they're just using that model to go and see, is that file going to be good or bad? I don't need to know what it's called. I don't need signature file updates. I don't need that file updates every few hours or every few days. Actually, I only update the product maybe every 6 to 12 months. So you can go an entire year without updating the product. And even if you don't update it after a year, you're talking about a fraction of a percentage, worse off in terms of your detection capabilities. So this is really a change of or moving of the goalposts when it comes to preventing malicious software from running on an endpoint. So what it means is a fundamentally new approach to endpoint security. You're using maths, or math if we're American, but you're using maths in order to learn from the past so that you can now anticipate and predict things in the future. So essentially what you've got now by using these sort of technologies, and what people like Cylance have created, is software that predicts and then blocks cyber attacks pre-execution. So nothing runs. You can try and double click on the file and actually, that might invoke a scan of that particular file, but nothing has to run. So it's essentially near real time, and you're going to block that based on using AI and machine learning. So very, very cool. And what are really the benefits as we start to get towards the end of this sort of presentation? What are the benefits of using AI on the endpoint? Well, it really comes down to 3 things: ESP, effectiveness, simplicity, and performance. So by effectiveness, in the AV world, they talk about efficacy, so a high efficacy rate. How good are you at actually blocking malware? The sad reality is, and I can say this because I have tested all of these AV products, and I've run most of these AV products in our malware lab at Ignition, and I create ransomware and I mutate existing ransomware. The whole idea is that you test all these sort of products out. Most of the signature-based technologies are about 25 to maybe 50% effective at best. Whereas these AI and machine learning technologies, you're talking the 99 point something percent effective all the time. So it's very, very difficult to get anything to go past them. So you might just buy something like this just for its high efficacy and its low rate of false positives. It might be simplicity is the key thing for you. So again, replace your existing antivirus technologies, your signature-based tools, with something that's using a bit of AI and machine learning. Lots of facts and figures out there. Forrester actually say it's up to 250% return on investment versus the traditional antivirus products. Most of that is because you're not rolling out daily patch updates and daily DAT file updates to all the machines. And there's some crazy statistic anyway that says something like 20% of all DAT files on all enterprises aren't even up to date in the first place. So even if you believed in the signature approach, you're not able to effectively implement it. And also that saving is also a reduction in the number of times you need to wipe and rebuild a machine because of an infection as well. Now, some people don't care about either of those top two. All they care about is performance on the endpoint. So because this is essentially maths, and at the end of the day, your computer is just a very big calculator, it uses about 1 to 2% of the CPU on your machine in order to do all of this magic, and about 40 to sort of 70 megabytes of RAM. It is incredibly lightweight. Anybody on this session today that's ever had a full system scan of an antivirus product running on their machine knows how slow it is, how long it can take, and how painful it can be from a user experience of then using the machine. You're now talking about 1 to 2% CPU, and as a result, your system will run faster. People have said to us, it's like they've uninstalled their antivirus software, or getting a new machine. When you first build a new machine, it runs that fast. And there's some other weird benefits as well, that actually you're no longer draining the machine as much. So batteries last longer, even hard drives last longer, because there are less reads and writes that are going on. So yeah, so very, very cool. And even, by the way, the malware that I created using that ransomware as a service bit of kit, it went through 75% of the vendors in the market, straight away without having to do anything at all. So yeah, very cool. Didn't have to pack it, didn't have to mutate it at all. So yeah, this is some real good reasons to implement some sort of AI technology. Last slide for me before I do a little summary and just see if there's any questions. So interesting worded slide, temporal predictive advantage. What on earth does this sort of graph mean? It basically means using these AI and machine learning technologies, before this piece of malware comes out, how many months before that piece of malware came out could you have prevented it? So in order to explain this better, I'm going to use the example of WannaCry that I'm sure there's a lot of people that are sick to death of hearing about WannaCry. But it came out, I think it was May 2017 off the top of my head, this was when it came out. Interestingly, it was one of CSI's customers that was one of the first people to be targeted with a piece of the WannaCry malware. Now, thankfully, they were running the silence technology, and it blocked 100% of all of the samples of WannaCry that hit them. And this guy actually sort of spoke at one of CSI's events previously. He was calling some of his ex-colleagues and co-workers to actually warn them that, look, this malicious thing is happening. It's trying to hammer us. We're okay, but just to make you aware. Unfortunately, most of the NHS were running another technology. I won't say the name, but it begins with S. And essentially they were hit. And as we know the rest of the story, that caused a bit of a problem. And actually, it wasn't just down to that AV vendor. A lot of the AV vendors weren't able to stop it. Now, me being a slightly odd individual, I then collected as many of the samples of WannaCry that I could after the couple of days that this was sort of happening, and actually just tested it against a load of products, again, in our malware lab. And I tested it with the current version of Silence, which I'd already been told was blocking all of them based on this particular NHS trust. And sure enough, even with it disconnected from the internet, if I dropped all the samples of WannaCry onto this machine, it blocked 100% of all the samples. I thought, well, that was pretty cool. But what if I now go back in time? So I took a version of Silence that was a year old, and again, installed it on a fresh machine. It had no internet access. It had no ability to check in with a sort of brain in the cloud and download any updates at all. Dropped all the samples again onto that machine, and again 100% were blocked. So this was very, very cool. In fact, you could go back 20 months, which is ultimately what this graph is showing you, that you could go back to a version of Silence that was 20 months before WannaCry existed or was created, for want of a better term, and using that version of Silence that was nearly 2 years old, you would have blocked 100% of all the samples of WannaCry that were seen and came out. So again, hopefully real world validation here that this is not just some sort of weird dream story. This is absolutely something that is real, absolutely that for the last few years has been protecting the planet. And in fact, it's such an incredible technology that BlackBerry a few months ago have actually acquired the company for $1.4 billion. And from everything we've seen from talking to the BlackBerry CEO and COO, everything's remaining the same. Silence is staying as a separate company just under the BlackBerry brand as well. And in fact, their last quarterly earnings call, which happened just recently, the Silence numbers have gone through the roof since the acquisition as well. So yeah, very cool technology, absolutely a real world piece of kit. And as we said, the benefits of using it are really the efficiency and the sort of efficacy of the product, the simplicity and the performance. So a little summarising bit for me before we just see if there are any questions, and then I'll hand over to Neill to sort of close it up. That AI is exploding in all sorts of markets. We've been focused on cybersecurity today. Healthcare, commerce, Internet of Things, cars, robotics. Even BlackBerry have 160 million cars connected that they're going to be deploying this sort of silence technology to as well. The challenge is absolutely cutting through the noise and finding the right technologies that work for your business. I don't think I've seen many products that work for every company of every size and every vertical, which is again why you need to work with the right partner to help you find the right technology for you. The opportunity is that you can create these better, faster, more automated responses to all of these different cyber attacks if you use AI correctly. This second to last statement has stuck with me actually for a few years. So we talked to Unit 8200 in Israel occasionally, which is basically their cyber hacking division of their army. So all they do is hack other countries and other companies. And I've had multiple dinners and lunches with the ex-chief exec and the ex-CTO of Unit 8200, and fascinating people to talk to. But they would say to me that on average, it takes just 2 days to break into any company anywhere in the world. That's the average, 2 days to get in. And this is the sentence that stuck with me. He said, look, as an attacker, you only need to be right once. I typically have the time, the resources, the capabilities to try all sorts of things over the course of hours, days, weeks, months, years. I've only got to find one chink in the armor, one way to get in, and I'm inside that company. But as the defender of the kingdom, defender of the castle, I have to try and be right all the time. I can't let anything lapse. I can't let the patching lapse or my vulnerability scans lapse. I need to make sure everything's up to date all the time. But then you've still got to try and cope with zero-day exploits and vulnerabilities. So the point is, if you're using and protecting your business using these AI-based technologies, you can make that even harder for these attackers. So I definitely leave you with that. There are some great bits of technology out there. Use the right things, find the right technologies, and work with the right partners, such as CSI. So the reason I say that, it's not about just finding the tech. You can have the world's best technology implemented in your network, but actually if you don't implement it in the right way, configure it in the right way, and manage it and monitor it in the right way, then you might as well have not bothered in the first place. So again, for anybody that wants to know more on this session today, I please encourage you to speak to your account manager at CSI or any of the people on this session today and try and find out a bit more. And hopefully we're all going to stay nice and safe together. So that's it from me. I will see if there are any sort of questions in the chat. And to Lena and Neill for inviting me to come and talk today. That is a real email address at the bottom of the screen in case you're wondering. Paul@ignition.technology if you want to get in touch. It doesn't look like, Neill, there's any questions that have come through in the chat at the moment, unless you can see anything different to me at all.
No, I don't see anything, but I'm sure people know how to get a hold of us if anything strikes them afterwards. One thing.
We have one. Yeah. Is there any impact on LAN, WAN with the particular product? So really good question. So if you think about the average DAT file of an antivirus technology that's using signatures typically, that can be anywhere from 50 megabytes per day to 250 megabytes per day. So absolutely with a signature-based product, what you're having to do is, even if you've got a central management console that distributes it, you're still having to download these 50 meg or 250 meg files to some sort of central server, across the WAN, but then maybe you can fire it out across the LAN. So you've still got loads and loads of data that's firing across your internal network on an hourly or daily basis. And in reality, you should do signature updates every few hours. And like I said, it's still not going to be the most effective thing. When you're using these AI and machine learning technologies, there's three different ways of deploying it. You could have it completely offline. And what I mean by that is there are no updates at all. It doesn't do any polling out across the LAN or the WAN at all. You could absolutely do it in a completely disconnected environment. And the only time you need to do an update is, like I said, every sort of 6 to 12 months, sometimes 18 months is the longest I've seen, where you can go between updates, and after 18 months, maybe you go around with a little USB stick and update those machines. You could do it that way. The sort of next one up is where you have a local management server. So all of the silence endpoints talk to that local management server, and they get their updates from there. But again, you're talking about a tiny update every few months. What they will do, if you configure the option, is when they look at a file on the machine, they will send the hash of that file, so just those little characters, to that management console in case the management console or the cloud has any further updates and intelligence on it. So, and the worst case scenario is where you don't have a local management console, you manage the endpoint, like I said, every 6-12 months, will download a little update to itself to update its sort of engine that runs locally. And again, the only daily things that go up and down is maybe these odd little file hashes. If they've not been seen before by that endpoint, they'll quickly send the hash up to the cloud just to see if there's anything else. So that was a slightly long-winded answer to say you're going to have minimal impact on the LAN and WAN, and in fact, you're going to see much less traffic normally than you would with a signature-based tech. Cool. Lovely. Well, Neil, I guess that is all from me. So I guess I'll hand over to yourself just to finish off.
Perfect. Thank you, Paul. Fascinating stuff, really. I mean, some of the statistics are just staggering, and you almost get to the point where you just don't believe them. The numbers are so big. But with AI on our side, it looks like we've got something that we can use to protect ourselves. So thank you very much, Paul, for presenting this morning. Thank you for joining us on this webinar. There will be a follow-up email with copies of the slides that will come out to you. So with that, I'd just like to say thank you very much for joining us, and have a great Tuesday. Thanks, everyone.